Today we're going to be talking about L'Hopital's rule, and we really need to know how to do derivatives before we can apply this rule. It's kind of funny how this involves limits. We studied limits at the beginning of calculus, but a lot of times we cover it later on just because you have to know all the derivative rules before you can apply L'Hopital's rule. Let's go ahead and take a look at why we need to know L'Hopital's rule. So this method provides solutions for limits of indeterminate forms. So what does the word indeterminate mean? Well, it's of the following type. So first of all, if you were to plug in a number for a limit value, say it's the limit at 3, to the top and bottom of a fraction, and you get 0 over 0, that is an indeterminate form. We don't know exactly what number that is. It's very open-ended. Same for negative infinity over infinity, infinity over infinity, or infinity over negative infinity. Any of these forms, when we plug a limit value in, means we need to use L'Hopital's rule, or at least try. There are other ways of evaluating limits, but this is your best bet when you get these indeterminate forms. If you plug a number into a function and you get one of these four scenarios, you need to use L'Hopital's rule. So let's go ahead and take a look at the first example. We have f of x equals sine of x over x, and we want to evaluate limit as x approaches 0 of f of x. So right off the bat, what we're going to do is we're going to plug this value in and see what we get back. Okay, so that's what step 1 says for us to do. So we're going to take 0, plug in for sine, plug it into sine, and plug it in for x right here. That should say sine, by the way. Anyway, we know that means sine. So sine of 0 over 0. What is sine of 0? According to the unit circle, it's going to be the y value, which is going to be 0 on the x-axis, and we get 0 on the bottom. So because we get 0 over 0, we have an indeterminate form. Means we're going to use L'Hopital's rule. L'Hopital's rule says if you do get an indeterminate form, meaning one of these forms we looked at before, then you just take the derivative of both the top and bottom. So let's take the derivative of the top and take the derivative of the bottom, and it's not the quotient rule. Okay, it's not f prime g minus f g prime over g squared. It's just the derivative of the top, derivative of the bottom. So the derivative of sine is cosine, and the derivative of x is 1. And what we're saying here, ultimately with L'Hopital's rule, is when you take the derivative of the top and bottom, it ultimately is still going to give you the limit of the original function. It's pretty interesting. If I have time for one video, I'll show you a proof as for why that works. But for today, we're just going to look at the examples. So now that we've taken the derivative, we're going to try to plug this value in again and see what happens. Okay, before we do that, I don't want to miss a step. We're going to simplify that expression, and we know that anything divided by 1 is itself. So for step 3, just simplify this down to cosine of x. Okay, now we're going to plug the 0 in and see what happens. And we're going to evaluate the limit if possible. So we're going to take that 0 and plug it into our simplified cosine of x, and we get 1 back. Now, why does this say if possible? It says if possible because sometimes we still get an indeterminate form. As long as you get an indeterminate form, you have to keep using L'Hopital's rule, meaning you keep deriving. So just keep that in mind for future examples. Okay. Next step is not needed for this example, but definitely should be remembered for future examples. And here is the step in case you want to write it down. Derive again and evaluate again if indeterminate. So if you were to take the derivative the first time and you still had an indeterminate form, you want to derive it again and again and again until it works out. That's L'Hopital's rule in essence. So that's it for example 1. In the next lesson, we'll look at next video, we'll look at example 2.